This video is created by Nihar from YouTube. This video is created by Nihar from YouTube. What is a transistor? A transistor is a type of a semiconductor device that can be used to both conduct and insulate electric current or voltage. A transistor basically acts as a switch and an amplifier. In simple words, we can say that a transistor is a miniature device that is used to control or regulate the flow of electronic signals. Transistors are one of the key components in most of the electronic devices that are present today. Developed in the year 1947 by three American physicists John Bardeen, Walter Brattain and William Shockley, the transistor is considered as one of the most important inventions in the history of science. Field effect transistor. FET is a key electronic component using within many areas of the electronics industry. The FET used in many circuits constructed from discrete electronic components in areas from RF technology to power control and electronic switching to general amplification. However, the major use for the field effect transistor, FET, is within integrated circuits. In this application, FET circuits consume much lower levels of power than ICs using bipolar transistor technology. This enables the very large-scale integrated circuits to operate. If bipolar technology was used, the power consumption would be orders of magnitude greater, and the power generated far too large to dissipate from the integrated circuit. Apart from being used in integrated circuits, discrete versions of field effect transistors are available both as leaded electronic components and also as surface mount devices. Metal oxide semiconductor FET, Mosfet. MOSFETs are made as ultra-low on resistance by the microprocessing technologies suitable for mobile equipment for low current consumption. Metal oxide semiconductor field effect transistors, MOSFET, are commonly used in microprocessors and related technologies for amplifying or switching signals. Junction field effect transistor, JFET. A junction field effect transistor, JFET, is the simplest type of three-terminal semiconductor transistor. JFETs are widely employed as electronically controlled switches, voltage-controlled resistors and amplifiers. The semiconductor material in a JFET is positively and negatively doped and arranged to form a channel for effective functioning of the device. Junction field effect transistors, JFETs, are depletion mode, since the gate junction would forward bias if the gate were taken more than a little from source toward drain voltage. Such devices are used in gallium arsenide and germanium chips, where it is difficult to make an oxide insulator. The junction field effect transistor is a three-terminal unipolar semiconductor device that has very similar characteristics to those of their bipolar transistor counterparts. For example, high efficiency, instant operation, robust and cheap, and can be used in most electronic circuit applications to replace their equivalent bipolar junction transistors, BJT. Cousins. Field effect transistors can be made much smaller than an equivalent BJT transistor, and along with their low power consumption and power dissipation makes them ideal for use in integrated circuits such as the CMOS range of digital logic chips. We remember from the previous tutorials that there are two basic types of bipolar transistor construction, NPN and PNP, which basically describes the physical arrangement of the P-type and N-type semiconductor materials from which they are made. This is also true of FETs, as there are also two basic classifications of field effect transistor, called the N-channel FET and the P-channel FET. The field effect transistor is a three-terminal device that is constructed with no PN junctions within the main current carrying path between the drain and the source terminals. These terminals correspond in function to the collector and the emitter respectively of the bipolar transistor. The current path between these two terminals is called a channel, which may be made of either a P-type or an N-type semiconductor material. The control of current flowing in this channel is achieved by varying the voltage applied to the gate. As their name implies, bipolar transistors are bipolar devices because they operate with both types of charge carriers, holes, and electrons. The field effect transistor, on the other hand, is a unipolar device that depends only on the conduction of electrons, N-channel, or holes, P-channel. Depletion type. The depletion type MOSFET transistor is equivalent to a normally closed switch. The depletion type of transistors requires gate, source voltage, VGS, To switch off the device. Symbols of depletion mode MOSFET. Symbols for depletion mode of MOSFETs in both N-channel and P-channel types are shown above. In the above symbols, we can observe that the fourth terminal, substrate, is connected to the ground, but in discrete MOSFETs it is connected to source terminal. The continuous thick line connected between the drain and source terminal represents the depletion type. The arrow symbol indicates the type of channel, such as N-channel or P-channel. In this type of MOSFETs, a thin layer of silicon is deposited below the gate terminal. The depletion mode MOSFET transistors are generally on at zero gate source voltage, VGS. The conductivity of the channel in depletion MOSFETs is less compared to the enhancement type of MOSFETs. Enhancement type. The enhancement mode MOSFET is equivalent to normally open switch, and these types of transistors require a gate source voltage to switch on the device. The symbols of both N-channel and P-channel enhancement mode MOSFETs are shown below. Symbols of enhancement mode MOSFET. Here, we can observe that a broken line is connected between the source and drain, which represents the enhancement mode type. In enhancement mode MOSFETs, the conductivity increases by increasing the oxide layer, which adds the carriers to the channel. Generally, this oxide layer is called as inversion layer. The channel is formed between the drain and source in the opposite type to the substrate, such as N-channel is made with a P-type substrate and P-channel is made with an N-type substrate. The conductivity of the channel due to electrons or holes depends on N-type or P-type channel respectively. MOSFET applications. The metal oxide semiconductor field effect transistor, MOSFET, or Mosfet, also known as the metal oxide silicon transistor, Mohs transistor, or Mohs, is a type of insulated gate field effect transistor, IGFT, that is fabricated by the controlled oxidation of a semiconductor, typically silicon. The voltage of the covered gate determines the electrical conductivity of the device. This ability to change conductivity with the amount of applied voltage can be used for amplifying or switching electronic signals. The MOSFET was invented by Egyptian engineer Muhammad M. Attallah and Korean engineer Don Kong at Bell Labs in 1959. It is the basic building block of modern electronics and the most frequently manufactured device in history, with an estimated total of 13 sextillion, 1.3 times 1022, MOSFETs manufactured between 1960 and 2018. The MOSFET is the most common semiconductor device in digital and analog circuits, and the most common power device. It was the first truly compact transistor that could be miniaturized and mass-produced for a wide range of uses, revolutionizing the electronics industry and the world economy, having been central to the computer revolution, digital revolution, information revolution, silicon age and information age. MOSFET scaling and miniaturization has been driving the rapid exponential growth of electronic semiconductor technology since the 1960s and enable high-density integrated circuits, ICs, such as memory chips and microprocessors. The MOSFET is considered to be possibly the most important invention in electronics, as the workhorse of the electronics industry and the base technology of the late 20th to early 21st centuries, having revolutionized modern culture, economy, society and daily life. The MOSFET is by far the most widely used transistor in both digital circuits and analog circuits, and it is the backbone of modern electronics. 2. It is the basis for numerous modern technologies. 3. And is commonly used for a wide range of applications. 4. According to Jean-Pierre Collange, numerous modern technologies would not exist without the MOSFET, such as the modern computer industry, digital telecommunication systems, video games, pocket calculators, and digital wristwatches, for example. 3. MOSFETs in integrated circuits are the primary elements of computer processors, semiconductor memory, image sensors, and most other types of integrated circuits. Discrete MOSFET devices are widely used in applications such as switch-mode power supplies, variable frequency drives, and other power electronics applications, where each device may be switching thousands of watts. Radio frequency amplifiers up to the UHF spectrum use MOSFET transistors as analog signal and power amplifiers. Radio systems also use MOSFETs as oscillators or mixers to convert frequencies. MOSFET devices are also applied in audio frequency power amplifiers for public address systems, sound reinforcement, and home and automobile sound systems.